Oh no, Coach Fred, what am I going to do? This figure looks like a parallelogram, but I'm not allowed to assume it. So how can I prove it? Well, guys, that's what we're going to do today. We're going to talk about methods of proving that quadrilaterals are indeed parallelograms. All right, so let's look at an example here. I give you a figure that looks like a parallelogram, but Coach Fred keeps reminding me I'm not allowed to just say it is. But I do tell you that TS is congruent to QR, so I'm going to mark my diagram, and that TQ is congruent to SR. And I look at this and I'm like, okay, I want to prove this as a parallelogram. In order for me to somehow prove this as a parallelogram, would I have to be able to prove that maybe opposite sides are parallel? Well, let's see how I could do that. Well, in the last chapter, I learned about congruent triangles. What if I connected Q and S with a segment? Well, if I did that, wouldn't that tell me that this is a reflexive side? So would this small triangle be congruent to this small triangle? And if I did that, wouldn't that make this angle and this angle congruent? And aren't they alternate interior angles? So then wouldn't the lines then be parallel? Oh my gosh, that's how I can do it. So let me see how I would get that written in a proof. Well, I've got my two sides. I need that third side. Coach Fred said we always need 3 sides or angles to prove a triangle congruent. So I've got to get my reflexive side in there by putting in QS is congruent to QS. And I know that with the reflexive sides, I always say they're reflexive is the property or reason. And now that I've got my 3 pieces, I can prove the triangles are congruent. The triangles are congruent because of SSS. So QRS is congruent to triangle SQT because of the side theorem. All right, so I'm going to call this then angle 1 and angle 2 to make it easier. So then I can say that angle 1 is congruent to angle 2 because of CPCTC. All right, that makes QR congruent to QS. It also actually makes, if the triangles are congruent, it makes this angle congruent to this angle, which makes these guys parallel. All right, so I'm going to call that 3 and 4. So angle 3 congruent to angle 4. And then that tells me that TS is parallel to QR and that TQ is parallel to SR because of the, now remember, we're proving lines are parallel, so the alternate interior angle theorem converse. Wow! So if the lines are parallel, then QRST is a parallelogram. I'm going to put it like that with the P inside. It's a parallelogram because of the definition of a parallelogram. The definition of a parallelogram is a quadrilateral with both pairs of opposite sides parallel. Woo! That was easy. I got it. Well, guys, there are actually 5 additional ways to prove that a quadrilateral is a parallelogram. We are going to prove them in class, but I'm going to give them to you now. So, number 1, if we can prove that both pairs of opposite sides are parallel, well, then it's a parallelogram because we proved the definition of a parallelogram, okay? But then what about those properties? Well, if we can prove that both pairs of opposite angles are congruent, then it's a parallelogram. If we can prove that both pairs of opposite sides are congruent, then it's a parallelogram. If we can prove that the diagonals bisect each other, then we can prove that it's a parallelogram. And there's actually one more, okay? One more case that's kind of I'm going to call it the funky case, the funky Comodina case. If we can prove that one pair of opposite sides are both parallel and congruent, then the quadrilateral is a parallelogram. Again, this is not one of the properties, but we're going to prove this in class tomorrow. If one pair of opposite sides are both parallel and congruent, then it's a parallelogram. That would look like this. Here it is. They're both parallel and congruent. That same pair. Now it doesn't have to be the top and bottom. It could be the sides. Parallel and congruent. All right, so now let's see if we can put this all to use. So explain how you can deduce from the given information that quadrilateral ABCD is a parallelogram. All right, I mark what I've got. So BE equals ED and CE equals EA. I can prove that this is a parallelogram because the diagonals bisect each other. So if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. All right, let's look at the next one. Angle BAD, okay, so BAD, so this whole angle is congruent to DCB, so this whole angle, and ADC is congruent to CBA. All right, well, I can prove that this is a parallelogram because in a quadrilateral, if opposite angles are congruent, then the quadrilateral is a parallelogram. All right, BC is parallel to AD and AB is parallel to CD. Well, this is a parallelogram because of the definition of a parallelogram. Okay, the definition of parallelogram says that if both pairs of opposite sides are parallel, so both pairs of opposite sides are parallel, then the quadrilateral is a parallelogram. All right, here we've got another one. BC congruent to AD and AB congruent to DC. All right, well, we just learned that if both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. All right, one more. Here's that funky case. BC parallel to AD. BC also congruent to AD. So because one pair of opposite sides are both parallel and congruent, the quadrilateral is a parallelogram. All right, I want you to skip this next problem. We're going to talk about this in class. You can read it and think about how we might be able to do that. But I would like to look at some examples, textbook examples, questions that you might have to solve in using this. It says, what values of x and y make the quadrilateral a parallelogram? All right, remember, if we can find a value that would make opposite angles congruent, then the quadrilateral would be a parallelogram. So I can set 4y equal to 100 and divide by 4 to get 25. So if y is 25, then opposite angles are congruent, so it would be a parallelogram. And the value of x, I'm going to do the same thing. I'm going to put 100, I'm going to put 80 here. So if 5x minus 5 equals 80, we add 5. So we get 5x equals 85. We divide by 5, and we get x equals, 17. If y equals 25 and x equals 17, then opposite angles would be congruent, so it would be a parallelogram. All right, one more. Find the values of x and y that would make this a parallelogram. Well, I look at it and I see sides. If I can find the values of x and y that would make opposite sides congruent, then it would be a parallelogram. All right, so I'm going to write equations making them congruent. So 2x minus y equals 28. Wait a second, there's two variables. So although it's linear, there's two variables. If there's two variables, that means I'd have to write a system of equations and solve using either elimination or substitution. Well, my other equation would be x plus y equals 14. Wow, these are set up perfectly to use elimination because I have one variable that has the same constant but opposite signs. So that means I'm going to add the equations together, therefore eliminating the y's. Those would get eliminated and we get 3x equals 8 and 4 is 12, 2, 3, and 4 is 42. So 3x equals 42. And so we divide by 3. And so x equals 14. Well, if x equals 14, then y would have to be equal to 0. And if those two things are true, then this figure would be a parallelogram because then opposite sides of a quadrilateral would be congruent and it would be a parallelogram. All right, guys, have a great day.